This is our last new lesson of the unit, and it's something that we've already kind of talked about before. If we take a look back, we've talked about this idea in terms of proportional relationships, right? So if we look back to 3.2, we had like 90 sit-ups, right? We had 15 sit-ups per minute. We had units. We were talking about a context, right? It's the same kind of thing here, except we're not always going to have a proportional relationship. Sometimes it'll be non-proportional. So what we're finding is the unit rate. That's just another word for slope. So go ahead and write a little arrow with the word slope. And a unit rate is comparing two quantities where the second quantity is 1. All right? So for example, if we had 60 miles per hour, right, what are the two quantities we're comparing there? Perfect. Thank you, Tariq. Miles and hours, right? 60 miles is my first quantity. 1 hour is my second quantity, right? So we're comparing them where the second quantity is 1. 60 miles in 1 hour. The ratio would look like this, 60 to 1. If we were comparing miles to hours, 60 miles per 1 hour. This is just review. Another example is we could have 135 beats per minute. All right, every song that you listen to has a certain BPM, beats per minute, a certain tempo. If you're listening to like Adele or something, it's probably going to be a lot slower beats per minute. If you're listening to like EDM or something like that, it's going to be a lot higher beats per minute, right? So 135 beats per minute. We're comparing the quantity of beats, 135, to the quantity of minutes, which would be what here? 1. Right? I heard someone say it. 135 beats per minute. Jadon. Yeah. Yeah, quick. Here. Super quick. Okay, so a non-example of this would be 100 miles every 2 hours. Who can help me out? Why would that not be a unit rate? Because the second number is not 1. Thank you, TJ. Right, 100 miles every 2 hours. How many miles would that be every 1 hour? 50, right? We just simplified. So 50 miles per hour would be a unit rate. 100 miles in 2 hours is not a unit rate because the second quantity isn't 1. It's 2. All right, it's just a little review of what we mean when we're talking about the rate of change or the unit rate. But in reality, it's just the slope. So we're going to find it the same way that we would find slope. Anybody in here have a savings account yet?
Yeah.
Anybody? A couple of us? Good. So let's say you turn, 13? Are you guys 13? Yeah. So let's say you just turned 13 and your parents want to open up a savings account for you over at, what bank do you guys use? Golden One. Sure. That's what I use. Credit One. Whatever it is. We're going to say Golden One. So let's say your mom takes you over to Golden One, right? Let's say you just had a birthday and you got $100 cash for your birthday. And she wants you to open up a savings account, put that $100 in. Okay? Now let's say you've also get a monthly allowance from your parents or your guardians, right? Where you do chores around the house and they give you $50 a month. Vincent, go ahead. Okay. Are you guys kind of visualizing this situation? Yeah. So you open the account with $100. Every month, your mom or dad or whoever gives you $50 as allowance. You're going to put that $50 in that savings account each month. Okay, give me a thumbs up if you're just vaguely understanding the situation I'm describing. Jasmine understands it. Avon, Cedric understands it. Gentleman over here in the front. Dylan, Andrew, University. Do you guys understand what I'm talking about? Do you understand what I'm talking about? Okay. So make sure you're paying attention. Okay. That's what this equation here represents. Okay. let's look at this graph. What is my x-axis here on this graph? What does my x-axis represent?
Time and months.
Time and months. What does my y-axis represent?
Total dollars saved.
Total dollars saved. Okay. So on my x-axis, right, each little square represents how many months? You guys taking a look? 1 month, right? Because here I've got 1 month, then 2, then 3, then 4. So let's fill in all of our months here. It's going to make our life a little bit easier. We could even go to 11 months if we wanted. Now, is each square on the y-axis worth $1?
No.
No. How much is each square on the y-axis worth? $50. Because halfway between 0 and 100 is 50. Between 100 and 200 is 150. Then we got 250, 300, all the way up. So we're just going to fill in our axis to make sure we understand what we're looking at. So, as the number of months goes on, the number of total dollars saved is going to increase. It's going to go up, right? So what is my M? What is my unit rate here? 50. Okay, as we know, M goes in front of X. I see in my equation that 50 is in front of X, so my M is 50. What does that 50 represent, though? $50 per what?
Month.
Per month. Again, we're comparing two quantities. The amount of dollars saved in a certain number of months. So my unit rate here is $50 per month. That's what I'm depositing every single month into my account. That's what this unit rate represents. Okay, $50 added to the account each month. The reason why we're doing this lesson last is because it's a little bit more challenging for most folks. So we're doing it as close to the test as possible so it's fresh in our brains. Okay? When it asks you to explain the context, to explain the slope in the context of the problem, it's asking you to put that number into perspective. What are we talking about here? Are we talking about 50 sit-ups in 10 seconds? No. We're talking about $50 each month, or in 1 month, exactly. Okay? That's what it means when it asks for the context. All right? Well, what is the y-intercept? If I look back at this equation, what's my y-intercept? 100. So B is 100. What does that 100 represent in this context that we've described? What does it represent? Hold on. Nair, what does it represent? Did you have your hand up? Money? It does represent money. Is it money coming in every month? Think about what we described the situation, right? You went and you started your account with your mom, right? What did you do when you started your account? You what? You save your money? Okay. How much did you initially put into the account? 50? So 100, right? You're putting in your $50 allowance every month, but how much money did you get for your birthday, we said? $100. So take a look. If we forget about the context for a second and we just want to graph this, we begin by graphing the point at 100 on the y-axis right here. What does that point represent? Well, it represents 0 months of saving, and you've got $100 in the account, right? So what does this y-intercept mean in the context of the problem? It means that you started the account with $100. right? And every month after that, how much money are you putting into the account each month?
50.
50. That's our unit rate. Go ahead, TJ. So you started with 100. You add $50 after your first month of allowance. How much do you have in your account now?
100.
You start with 100.
150.
You add 50.
100.
What do you have now?
150.
150. Okay. So after 1 month, I should have $150. You guys with me still?
Yes.
How much would you have after 2 months?
200.
200, because you add another 50. 2 months, 200. That $100 at first, your first 50, your second 50, altogether that's 200, right?
Yeah.
So what am I rising by from point to point?
50.
I'm rising 1 square, but 1 square is actually $50. Right? So I'm rising 50. How many months am I running over? 1. What's 50 over 1? 50. And that's what we said our slope was, okay? So if we're thinking about what we just did on worksheet 10, right? I begin at my B, there's 100. 50 over 1, it's $50 in 1 month. I'm going to rise 50, run 1, make a dot. Rise 50, run 1, make a dot. And I'm going to keep going all the way up. I'm going to follow that pattern as far as I can, just like I always do. Sorry. I'm going to line these up. I'm going to make my line. Now, what do we notice about this graph that's different than the graphs we saw in worksheet 10?
X.
Yeah, what's different? It doesn't go past what? It doesn't go past the origin. That's right. We're only looking at the first quadrant. Why are we only looking at the first quadrant here? Yeah, Cedric.
Because we can't have negative money.
Exactly right. We can't have negative months. We can't have negative money. Okay? You started the account with 100 and you're only putting money in. You can't have negative money. In the real world you might be able to, but not in this problem. Give me a thumbs up if you see how we graphed that line. Okay, it's exactly the same as what we've been doing, except the numbers are a little bit more inflated based on what we're talking about in that problem. Now the real question is, how much money's in your account after 10 months? How can we figure that out? Just look at the graph. Where is 10 months on the graph?
Number 10.
At the number 10, on the bottom, right here. So take a look. At 10 months, I'm going to look all the way up.
600.
I'm going to hit that point. I'm going to look all the way over. Are you guys okay? How much money do I have at 10 months then? $600. You just looked at the graph. Okay, if you're talking right now, don't ask me no questions on the worksheet. It's getting old. Another way that we could have figured this out is we could have just taken our equation.
Times it by 10.
That's right, and we could plug in 10 months. Right? $50 a month for 10 months. What's 50 times 10?
500.
500.
Oh, okay.
Plus the $100 you put in to start leaves you with how much in the account?
600.
$600 total. Is that the same amount that we got by looking at the graph?
Yeah.
Yes. So there's always more than one way to get to an answer. You could look at the graph. You could use your equation and plug in the number that it gives you and solve it out. Either way, you should get the same thing if you did it right. This is absolutely something you will have to do on the test. So what questions can I answer about that? Okay. Let's take a look at the next piece real quick. Somebody saying. All empty? Okay, just give me a second, please.
Hey, can I get it? Hey. This is my. Oh, that's when I saw your information. Yes, you are. Like a couple minutes ago. The last focus so far. It's on back. That's the next one. So they all come like with them. When I first when I worked from Thursday and the second one comes in October. Letting me take that. I have one for you. Don't test me.
So that first page, that was the hard part. This is the easy part. Oh yeah, this is the easy part. So in order for us to have a linear equation, what does a linear equation look like on a graph? A line. It doesn't have to be through the origin, right? What type of equation goes through the origin? Proportional, right? Linear just means a straight line. Yep. The first four letters are line. So a linear equation is just a straight line. Could have a negative slope, could have a positive slope, could go through the origin, could go through something else. Right? If it's a linear equation, it's just a straight line. So in order for us to have a straight line, our slope, or our rate of change, has to be constant, not variable. Okay? What's another word for constant? Repeating, consistent, same. What's another word for variable?
Different.
Letter, good.
Or
I would say different, right? A variable is a letter. But the reason why we call letters variables is because they could equal different numbers depending on the problem. Right? Okay, guys, let's all just focus on this, please. So we need to find a same or a constant change. We don't want to see a variable change. So let's take a look. What are the two quantities I'm comparing in table A? What am I comparing here? Okay, someone help me out. What are the two things I'm comparing here? Yeah, Vincent.
Push-ups and then time.
Perfect. Push-ups and time in what? Okay. Push-ups in a certain number of seconds. All right? So what I want to do, or what I want to do, is I want to figure out if my change in X and my change in Y is constant or not. To do that, I'm going to do what I always do with a table and make my little arrows. All right? How do I get from 5 to 10 seconds? Plus 5. How do I get from 10 to 15 seconds? Plus 5. Are those numbers the same?
Yeah.
Okay, so far, so good. My triangle X, or my change in X, is plus 5. In terms of my push-ups, how do I get from 6 to 12? Plus 6. How do I get from 12 to 18? Is my triangle Y, or my change in Y on the bottom, the same?
Yeah.
Yeah, it's plus 6 and plus 6. That would be constant. Exactly, Tariq. Table A has a constant rate of change. Okay. So my change in Y and my change in X were the same. Right? That makes my relationship constant. Let's take a look at my second table. I'm still comparing the number of seconds to the number of push-ups. How do I get from 5 to 10 on the top? How do I get from 10 to 15? So far, so good. Triangle X, right here. Triangle X. It's a little triangle with an X. Are you talking about right there? And? Yeah, that's an and. My change in Y and my change in X were the same. So on the bottom here, how do I get from 4 to 7? Plus 3. How do I get from 7 to 12? Plus 5. Is my change in Y the same here? No. What happened to this person as they were doing push-ups? What happened to their speed? They sped up. Right? They did 3 push-ups in 5 seconds, then they did 5 in 5 seconds. So they're getting faster as they go. If you're getting faster, that's not a constant speed. That's what we're looking for. So table B, my change in Y was different. Therefore, I had a variable rate of change. I wasn't doing push-ups at a constant rate over time. Okay? If I were to graph that, right, if I had a graph here where this is seconds and this is push-ups, right, he's going at this speed for a little bit, and then all of a sudden he gets a lot faster, and the line looks like that. Is that one straight line to you? No. So that would not be a linear relationship. Mohammed? Yeah. Good. All right. So it's very easy for us to figure this out. If I look at number 1 down here on the bottom, what am I comparing in number 1? Hot dogs per minute. That's right. How do I get from 1 to 3 on my minutes? +2. How do I get from 3 to 5? +2. So far, are we constant? Yes. Okay, just focus on this. For my hot dogs, how do I get from 4 to 12? +8. How do I get from 12 to 20? +8. Am I constant on the bottom too? Yeah. So is this a constant rate of change or a variable rate of change? Constant. If it's constant, we can find a slope. Good. If we put my y over my x, 8 over 2, what is 8 over 2? 4. 4 what? 4 miles per hour? 4 what? 4 hot dogs per minute. We got 4 by taking my change in y, which is 8, dividing it by my change in x, which is 2. 8 over 2 is 4. Right? And we see right here, this person can eat 4 hot dogs in 1 minute. Take a few seconds on your own. Do 2, 3, and 4. See if you have a constant change or a variable change. Give it a try on your own. And then we'll get going. That's right. Because it's not going to be a straight line. It's going to be something wrong. You say variable. If it's constant, then you can find your slope. If it's variable, you're down right there. That's a good question. That's a good question. So give this one a try. Do your little arrows and see if you have the same numbers on the bottom and top. Good. Good. So is that the same on the bottom or the top? Sorry. Is it the same numbers on the bottom? No. So that will be big.
Do you have a lead?
I do not. But I have pencils. Do you need a pencil? No? Okay. If you need a pencil, then I'm right there.
I just use the lead pencil sheet.
Yeah, just make sure you get that. Good. And if it is constant, find the M. Good. For what? Per. That's right. Great job.
Wait, can I do this? Can I select that?
Was that?
Can I do that?
Yeah, 4 hot dogs per minute. That's fine. Perfect. Great job. Okay. How's it going? We gotta get started. Okay. Good. Okay. So do we have the same change in laps on the bottom there? No. So is that going to be constant or variable? Perfect. So we're going to write variable and box it up. Good. Perfect. Okay. Okay. Do we have the same numbers here then? So is it constant or variable? Perfect. That's your answer. Variable. Right, this one was constant. That's right. That one's variable. Different numbers. All right, it all looks pretty good. Let's take a look just to make sure. For number 2, we're talking about laps per hour. Okay. On the top, I've got +2 plus 1 plus 1. What do I got on the bottom? How do I get from 12 to 20?
Plus 8.
Okay. How do I get from 20 to 24?
Plus 4.
Is 8 the same as 4?
No.
No. So what type of relationship do we have here?
Variable.
A variable rate of change. This person slowed down as they went on. Right? The number of laps decreased in the same number of hours. For number 3, I got +10 plus 20. And then +10 plus 30. That is super variable. Right? Number 4, I've got +2 plus 2. How do I get from 18 to 26? Plus 8. How about 26 to 34? Plus 8. Is that constant or variable? Constant. Now because it's constant, let's find M. My M is going to be equal to the change in Y over the change in X. What's 8 divided by 4? 2. 2 what? 2 dogs per hour, 2 miles per minute. What is my 2? Perfect. That's right. Shirts per week.
How do you get 4?
How'd you get 4?
Whoa.
Oh, sorry. I'm not very good with numbers. That's my bad. Okay. I had him in the wrong spot. 8 divided by 2 gave me 4 shirts sold per week. TJ? It was a joke. Yeah. All right. Any questions I can answer about that? Like I said, that's the easy part. Okay.